you guys to think about who's your favorite teacher so far? And it can be kindergarten all the way to the current grade that you're in right now. Who is your favorite teacher so far? What makes that person a great teacher? You guys are so sweet. Yes, Miss Jody. Oh, she was so fun, right? Um, so yeah, I like to be serious when it's needed, but I like learning to be fun because some kids just don't like school, right? So why not make it fun? I don't like to be too serious, but there are times to be serious. If behavior is bad, obviously I'm a different teacher. But if behavior is good, hey, let's have fun just for the interest of time here. I'm going to put that Blicket code in one more time. So distance, we know, is a scalar quantity, okay? Distance refers to how much ground an object is covered. So think about it. If you're running a race, you're running 3.1 miles or 5 kilometers, 10 kilometers, you're running 26 miles, whatever. You have a distance. It's how far you cover on ground in a car, how far you drove. So remember that scalar quantities are fully described by magnitude or a numerical value alone. That's it. What is displacement? Well, displacement is a vector quantity. This refers to how far out of place an object is from their original change in position. So this one, we're going to talk about magnitude and direction. Okay, so this one, we have two components to it.
Today we're going to talk about the difference between distance and displacement. If this car moved from point A to point B, we could say it traveled a total distance of 100 meters. Distance is a measurement of the length between 2 points. Now let's go back to this example and add another road sign here. Let's bring this one in so we have a direction. Now if the car again traveled from point A to point B, we could say that it traveled a distance of 100 meters, but we can add in another part of this measurement. We could say it traveled 100 meters to the east. And this is actually a displacement rather than a distance. The difference is that we're including a direction this time around. Now the definition for displacement is the overall change in position. So we're looking at a starting position comparing it to a finishing position. And then the other big difference here is that displacement is going to include a direction. Now displacement includes a direction, and so we call this measurement a vector. And so measurements that include directions are called vectors. Distance doesn't include a direction, and so it's called a scalar.
Distance and displacement are words that describe the motion of objects. They're both talking about this thing moving. Distance is a scalar quantity and refers to how much ground it covered. If we went and drove 6 hours in one direction and 3 hours back because we forgot something and another 6 hours, we would describe that entire time that our car or our bike or whatever was moving. Displacement is a vector quantity, refers to how far out of place it is from the starting point. So we have to know its starting point and its ending point, and we're talking about its change in position. Displacement must also include a direction, left, right, north, south, east, west, up, down, whatever it is.
Now this line looks a little bit steeper, so let's watch what happens. Can you see how the man's moving faster? And now let's watch the man at the end. The man, whoa, really moved. And so the slope of this line also tells us the speed. And so that's the first rule. First rule that you should pick up, at least that I've picked up, is that the slope equals the velocity. And if there's no slope, so if slope equals 0, then the man's not moving at all. So here. If the slope is negative, then the velocity is negative. And it doesn't mean that it's somehow going slower, it just means that it's moving in the opposite direction. So it's moving down like that.